Coming for the next topic, that is the angle of deviation. So what do you mean by angle of deviation? So here I am taking this is a plane mirror, and so here I am taking, so here it is a normal, here it is a normal, and so here is the plane surface. So here is the plane surface, and an incident ray, a ray is incident in this particular direction, a ray is incident in this particular direction, but reflected in this particular direction, reflected in this particular direction. Okay. So this angle is I, and this angle also will be equal to I. Why? Because basic law of reflection here now we know angle of incidence is equal to angle of reflection. Angle of incidence is equal to angle of reflection. But here, if you can see here now, actually this light ray have to come in this particular direction. Okay, now this is what? This is the actual direction of incident ray. Actual direction of incident ray, actual direction of incident ray. And so here it is converted, so here it is a reflected ray. So here it is a reflected. So the angle between this actual direction of the incident ray and the reflected ray, that is converted, that is the deviation. So what is the total angle from here to here? The total angle from here to here, I'm getting this is how much? This angle will be 180 degrees. Okay, now 180 degrees. But here in this, it is covering how much angle from here to here? It is covering an angle of how much? 2i. So what is the angle covered from here to here? The angle between this actual direction of incident ray and reflected ray. So what I'm getting here, no, that is 180 minus of 2i. 180 minus of 2i. So therefore, what is the basic formula for deviation? Delta is equal to that is the 180 minus of 2i. If angle of incidence I is equal to theta, then the formula for the angle of deviation will be that the 180 minus of 2i, 180 minus of 2 theta. Okay. Now, let us see some particular conditions in this particular angle of deviation. So, when it is a maximum and when it is a minimum. Okay. If incident ray, if incident ray, if incident ray is along the normal, if incident ray is along the normal, then then deviation delta is said to be maximum. Then deviation delta is a maximum. So how can we get this? Okay, suppose if at all, if I'm taking this is the plane mirror, so this is the plane mirror, and so here I'm taking, so here it is the normal. Okay, so here I'm taking this is the incident ray. This incident ray is directed along the normal, right? This incident ray directed along the normal. So what is the value of I value here now? I value is equal to 0. So if I value is equal to 0, then what is the formula for delta? Delta is equal to the 180 minus of 2i, and that value of I value is said to be 0. If you substitute the value of I is equal to 0, then delta what you are getting here is a 180 degrees, which is the maximum. Delta maximum is equal to that the 180 degrees, when incident ray is along the normal. Second condition, if incident ray is along the, sorry, if ray is if ray is just grazing on the surface, if ray is grazing on a surface, if ray is just grazing on surface, if ray is just grazing on a surface, so here what you are getting here now. So what does it mean that? So what is the situation? So here it is a normal. So this is the normal. And so here it is a plane mirror. This is a plane mirror, and ray is just grazing on this particular surface. So here, what is the angle from here to here? This angle is said to be 90. So what is the value of I value here now? I value here you are getting as a 90 degrees. But you know what is the basic formula for delta? The basic formula for delta value will be nothing but that the 180 minus of 2i. And here, what is the value of I value now? I value is 90. So if you substitute, delta is equal to 180 minus of 180. So here what I'm getting here is 0. So which is nothing but which is the condition for delta minimum. Delta minimum is set to be 0 when ray is just grazing on a surface, and delta, sorry, Delta is said to be minimum when ray is just grazing on a surface, and delta is said to be maximum when ray is just incident along the normal. When a ray is just incident along the normal. Yeah, in this particular question, they were telling two plane mirrors are inclined to each other at an angle theta. Okay, so two plane mirrors they are inclined at an angle of theta. A ray of light is reflected first at one mirror and then at other. So find the deviation suffered by the ray. Okay, na? For this particular question, how to solve this particular numerical. So here I am taking the two plane mirrors. How are they now? They are inclined at an angle of theta. They are inclined at an angle of theta. Okay. So here I am taking this is the first mirror. Anusha, Anusha, charger తీసుకుంటా తొందరగా. So here, the two mirrors, they are inclined at an angle of theta. So here I am taking, so here it is M1 and here it is M2. So what is the angle between them? Here is theta. So what they were telling, a ray of light is reflected first at one mirror, then at other. Okay, so here the two plane mirrors they are inclined to each other at an angle of theta. A ray of light is incident first at one mirror and then at other. So here I need to find out what is the total deviation suffered. Nothing difficult is there. So here how many normals will be there? Two normals will be there. So here the first normal and so here it is the second normal. Okay na? N2. So let me imagine this is the first time when it is incident and the second time when it has been again it has been reflected. Okay na? Sorry, here it is second one and here it is under that is the final reflected ray. So here it is a final reflected part. So here I am taking the angle between incident ray and normal. I am taking this angle is how much? This angle is alpha. So automatically this angle also will be equal to how much? Alpha. So if you take this angle is alpha, we know the total angle from here to here is 90. So this is alpha. So what about this angle here? Now there's a 90 minus of alpha and second ray, sorry, after this particular reflection, this ray is incident on this particular second mirror. Let me imagine this angle of incidence is a beta, angular reflection also will be equal to beta. So here, normal always makes an angle of 90 degrees with respect to the plane. Okay, na? So total angle is 90 from here to here. Actually, if at all, if you can see, so this is the plane, and so here it is the normal. The total angle is equal to how much now? 90. But already beta is an angle covered. So this particular remaining angle is equal to what I'm getting here now. There's a 90 minus of beta. So if you look at that particular triangle, the summation of all the three triangles, like the final triangle, it is looking like this. If you can see very carefully. So this angle is equal to how much? This angle is equal to theta, and this angle is equal to it is 90 minus of alpha, and this angle is equal to that is the 90 minus of beta. So first of all, actually, what is the relation between alpha and beta? So let us see here now. So we know that the summation of all the three angles in a triangle will be equal to 180. So consider that. So what you are getting here now, that the theta plus 90 minus of alpha plus 90 minus of beta, summation of all the three angles is equal to what I'm getting now 180 degrees. Okay. So 90, 90, 180 and 180 will be getting cancelled. So theta is equal to what the value here now? Theta is equal to that's the alpha plus beta. This is the primary relation. So what we are getting between the theta and alpha and beta. Okay. So here it is the first case and here it is second case. Okay na. So for the first case, what the deviation produced? The delta 1 is equal to, so what are the value, what are the formula here now? 180 minus or 2 times of what is the angle of incidence here now? Angle of incidence. So here what I am getting here is alpha. Delta 1 is equal to what the value here now? That's the 180 minus of alpha. And second case. Finally, when the ray is coming out again, delta 2 is equal to that is the 180 minus of 2 times of second case, what is the angle of incidence now? Beta, right? So delta 2 is equal to that is the 180 minus of 2 beta. So total deviation will be nothing but total deviation, net deviation produced, delta net will be equal to the delta 1 plus delta 2, which is equal to 180 minus of 2 alpha plus 180 minus of 2 beta. So what I'm getting here now, 180 plus 180. So this will be nothing but that the 360 degrees minus of 2 times of alpha plus beta. And we know that what is the value of alpha plus beta here now? Alpha plus beta is equal to theta. So 360 degree means how can I write now that the 2 pi minus of 2 times of theta. This also can be written as the 2 times of pi minus of theta. So this is the formula for this is the value of total deviation produced for this particular numerical. Okay.